Welcome you all on this Abaqus Python YouTube channel. This is a series of lectures going to be on the Abaqus Python scripting, and this is the first lecture in this series. So in this series I'll be explain you about the Abaqus Python scripting, the concepts behind these and how you can use it. In this first lecture I'll be explaining about what is Abaqus Python. So first of all, the contents. First of all, we'll learn what is Python. So this is a more of a Abaqus related introduction. So it's a very much brief introduction, and then we'll learn about why an Abaqus user, existing Abaqus user, should learn Abaqus Python. And next we'll try to we'll learn various methods that are available to run the Abaqus Python scripts, and later we will learn how we can access the Abaqus Python interface. So this is basically to make use of the Python interface to write the code, write the Python code for our task. At the end we will be going to learn about some examples of this. So let's get started. So what is a Python? So I think most of us have heard that Python is a programming language, and it's something called object oriented language. So these are the basic fundamentals that we required for our this lecture series. So let's explain and go deep into that. So everything in the Python is an object. So and whatever the syntaxes or the logic or the development has been done about Python is all is related to these objects. So you have some objects, and they have some characteristics, and you can use some methods or functions to manipulate that data. So basically the structure is like that. So you can consider any object. Let's take an example of a person. Okay, so a person, let's say that person has some characteristics and some actions or behaviors. Okay, so let's categorize the information in those categories. So first the attributes or characteristics, right? So a person has the height, or he has the age, right? He has some profession. So these are some information related to him, right? So what are the methods or behaviors? Okay, so he can run in particular fashion, he can work in some particular fashion. So based on the attributes, he has some actions related to it. So you can see that attributes are very much influencing the methods here, right? So that is one take we can take here. And let's take another example on the Abaqus step, right? So everybody might have used the different step analysis, right? Static analysis, viscoelastic analysis, right? So let's take a step as an object. So as an object, step has some attributes. So what type of attribute it can have? It can have name, so it will have the name, it will have the step number, and then it will have some nonlinear geometry option, whether it is on or off. So if it is a nonlinear case, then you might be required to on this option, right? So okay, these are some characteristics. So what you can do with it? So there are some methods. There are various methods actually. So these are some basic ones like get frame, right? So you can use this method to access some particular frame in that step, right? And the other one is frames. So in this method it will give you the array of the frames. So whatever the number of frames it has, the step has, all the step frames it will give you. And the last one is is a set default field. So you can define any default field. Whenever you switch on to this step, then you will get to see that default field there. We know this, but how we are going to use it, right? So just a small example here. So we are using here something called the dot notation here. Whether you are accessing the attributes or whether you are using some method on it, you have to use this dot notation. So how we are using it? So let's take an example, right? So this is the ODB object, right? So this is the ODB object that we have created, we have opened one ODB file, and that there we have created this ODB object. If you have to access the steps inside this ODB object, then we have to use this dot notation, and then this steps. So this is the method. So what it will give? It will give all the steps inside that ODB. So you have to use this brackets, square brackets to use the particular method. Okay. So now you have the step 1 data till here, and if you want to use further the frames inside that step, then you have to use this particular frames method. So what it will give again? It will give an array of frames, right? It will give all the frames available in that space in that step. So again we are indexing to 1, so this will give the second frame. So basically it will start from 0, so 0 1 2 3, so 1 is nothing, 1 corresponds to the second frame. Again we are using the same notation, dot notation, and we are accessing the field outputs. Here we are accessing the U, that is the displacement output. So after this we are trying to access the data. So in this till here in the field outputs U, so till here you have the displacement data, right? So from this, what I'm again using the values method to access the data from that particular field output. So I'm again indexing this 0. This 0 means the first entry for this field output. So it can correspond to the first node actually, because this displacement is a nodal quantity, right? So that's why it's 0 means the first node data. Here you will have the all the information related to the first node. Okay. So I'm then at the end, what I'm doing, I'm here using the data, right? It will give the values, okay, for that field output. So you can see the dot notation, how useful it is. So you don't have to write bunch of lines of code. You just in the same line you can get the data. So that's why this object oriented concept is useful here, right? So Python it requires no precompile. So whenever you have to write a code, you have to create some script. There are still 3 steps you have to do. Basically you have to write the code, you have to compile it, and then you have to run it, right? So C++ or Fortran codes, they require the compiler actually. So the compilers can be licensed one or free also, but in our case Python doesn't require this compiling method, right? Compiling process, it's not needed. So basically what you can do is you can write the code and you can directly use it, right, or run it, right? Other important thing is it requires no declaration of variable. The Fortran code, what you have to do is you have to define the variable. So what is the type of that variable, and then you have to write the name of that variable, right? But in Python you don't need to do that. So you can directly use the variable and assign the value. In Fortran you have to declare it first, you have to specify the type, and then you have to assign the value, right? So there are 2 steps involved here, but in our Python it is not required. For the beginners, I think this is the best thing that is there in the Python. So for a beginner it will be very much easy to learn the Python compared to other languages. Obviously it is a relative, so it's a very much simple to learn. There are a lot of resources available, YouTube channels available, you can learn from there. Reason why it is more easy, because many of the syntaxes are more of a human readable form, so you can directly read the language, right? So that is a very much easy. That's the reason it is very much easy to learn this language, right? And the last one is the usage of the modules. So what a module is, basically a bunch of code, some lines of code. So for example, you have written some logic, and you can, if you have stored in this file, you can consider that as a module. Okay. So basically what this is, why this is useful here is, let's say you have written some code, you want to send it to someone else for the further use, right? Basically how they will going to use it. So the normal way of saying it, you can copy the data and directly paste it into the main code, right? But at the end that will going to be that will make the code easy messy, right? So you don't know, because if you have copy pasted that code, then there might be some variable duplication and that sort of stuff, right? So to avoid that, you can import that file as a module. So there is a function called import and then the file name. So that way you can use that code without affecting the other lines of code there. So that is one of the main usage point of view. It's a very much good thing. So next, as an Abaqus user, why you should learn Python? So why, what kind of things you can do with the Python, right? So using the Python functionality, right, you can use some use the or analyze the data structure, Abaqus data structure. So whether it be let it be model database or output database or ODB data files, right? So all this data, you can read it, you can interact with it, you can do stuff with it, and basically it will enhance your capability, right? So other thing you can do is, there are a lot of functionality available here, right, in the Python, in the Abaqus. So all this functionality you can access and manipulate using this Python interface. So in a sense, you can create your own logic, you can create your own modules. So there are basically default modules are there, right? Part, material, assembly. So basically you can create your own module, you can create your own plugins, and you can, this way you can extend your functionality a lot more, right? So in a details, what else we can do, right? So you can automate your repetitive tasks, lot of pre and post process tasks you might be doing manually, so that you can automate using Python. You can mathematically post process your ODB data. So you can create some fatigue output from the stress data or strain data, or you can create some new output using this data. Other thing you can do, you can create this new GUI also. As I said, you can create some default, your customized module, so that also you can do. And you can do some parametric study also. So when you are using GUI, you might have created some models, and you might have to check this model for different parameters, right? So different heights, different weight, right? So if you are using a script, you can do this parameter study very much easily. So you just have one script, you just have to submit this script, and you can write the logic that you just have to change some parameters, so it will do that quickly, right? Yeah. So next thing is how you to run the Python script. So let's say you have written some code, written some Python script. So how are you going to run it? So when you open your Abaqus, so your screen look like this, right? Okay, not particularly like this. So you'll have this start session window, right? So this on the window, in this window, you can see this run script option, right? So you can directly click this option and select the file, and it will directly run in this Abaqus CAE. Other way you can do is, you can see here the file menu, right? So you just have to click this file menu, so it will open lot of options here. So at this point you can see this run script option. So if you click this option, then you have to just have to select this particular script, and it will run into this Abaqus CAE domain. Alternatively, you can see the shortcut also, that also you can use. Okay. And the third way of doing is this command line interface. So at the bottom of your Abaqus CAE window, you can see these two options, right? So the first one is the message area. So this will be the default one. So if you click on this, the second option, so this option we call it as a command line interface. So basically this means is you can write any lines of code here, any Python code or Abaqus code you can write here and run it. So that's why it's called as, I think, a command line interface. So from here also you can run your script. So you just have to write this execute file. This method is the built-in method, and where you have to specify your Python script name. And just to give you a small note here, so if your script is stored in the same working directory, then it's okay to just specify the name of the file. However, if your script stored in some other 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 folder other than your work directory, right? So then you have to use here the full path of that script, not just the name, right? Yeah. So how else you can run this script? So what was the common thing about these three methods? So there are three methods, right? 1, 2, 3. So three way you can run the script, but what is the common? You have to launch the Abaqus CAE, right? Abaqus CAE or Abaqus Viewer, depending on which domain of script you want to run, depending on that. But at the end you have to launch this Abaqus CAE or Viewer, right? The other way of running is using the command line, command prompt, or Windows PowerShell, right? Or Linux user can directly use the terminal also, right? So I'm explaining the methods here for Windows PowerShell. However, same commands you can use for command prompt, and for Linux user you can use the terminal also. So what is the first method is, so you have to write this Abaqus. So this basically fetches the Abaqus .dot file. So it's a default command to invoke the Abaqus. Then you have to the second option is the CAE, right? So what basically it's doing is from the Abaqus it's launching the CAE. Okay. The third option we are giving here is no GUI, right? So no GUI and some file name. So what it's doing is it's running this example Python script without opening the GUI. So in the previous slide you have seen the Abaqus CAE GUI, right? So it will not open that, and it will run this script. So again, this example.py script is in this work directory. That's why I have just specified the name here. But if you want to use use the script which is not in this directory, right? So you have to specify the full path here. Okay. So that's just a point to take care of. Okay. Other way you can use the viewer option instead of CAE. You can use the viewer option, right? So what it will do is it will run this script in the viewer. So obviously the obvious difference will be like this functionality, Abaqus CAE. This functionality you can use the CAE options as well as the viewer option, right? So as you know, whenever you launch Abaqus CAE, you can see the visualization modules also, right? So basically it will take all the tokens, so for the CAE as well as the viewer. But specifically if your script is only using the viewer option, then you can directly write viewer and the script name. So in this case also it will not launch the GUI, so backend only it will run the script. Okay. Third one is very much interesting and useful, right? So the commonality between the first and second option is it's using the Abaqus license. Definitely it will going to use the Abaqus license, right? So this will use the full tokens, Abaqus CAE full tokens, and viewer it will use some lesser token. I'm not sure the exact number of tokens it will use, but at the end it's using the Abaqus license, right? It is using the some number of tokens. But we are writing here instead of CAE or viewer, we are writing the Python, right? And what this doing is it's just using the Python interface, and if you are running your script using this command, it will not use the Abaqus license. Obviously it will have some limitations because Dassault system company will not allow you to use their all functionality without needing their license, right? So but there are some limitations, but I think for your ODB data post processing, right? So most of the time, 99% of time, I think using this option is very much sufficient. So now how to use the Python interface of Abaqus, right? So if you launch this Abaqus, So here you can see this command line interface, right? I already have explained you. So here what you can do is you can write some bunch of lines of Python code. So here I have written this, like I'm creating one ODB object from the viewport, right? And accessing some step data, then accessing the field data, what type of field data it has, right? So this is the one way. What else? So this one, right, I have told you Abaqus Python. So if you have typed this Abaqus Python, it will launch this Python interface. So as I told you, this will not use the Abaqus license, but still you can use this some commands. So still you can open ODB and manipulate the data, write the data, okay, and play with it, right? So there are some limitations we're not going to discuss at this point. Let's take an example and let's go one by one here. So first what it is doing, it is importing some modules, right? So this is these modules are very much Abaqus related modules, okay? So Abaqus module, then Abaqus constant module, C modules, and so on, right? So what we are doing here is we are creating here the model. So what is the name of that model is model A. So in the MDP object model, so we are using again the dot notation here, right? So in the dot notation there is one method called model, okay? So you just have to note that the M in the model is a capital one. So these are the special methods that are that are created, okay? So what this does is it creates the model. So whenever you see capital one, it's creating the that object. So here we are using the model, so it will create the model object, okay? So we are giving the name as a my model, okay? And next what we are doing in this my model, we are creating one sketch object, constrained sketch object. So whenever you click on the part module, and it will open some grids of lines of window, right? So that is what we are doing here. The sheet size we are specifying and something, okay? Then what we are doing here is in this sketch object, we are creating some lines, right? So what we are doing basically here is we are drawing the model sketch, right? In the my model, we are creating one part here, right? So again you can see, right, the part P of the part is capital one. So what it is doing, it creating the part. So that's why in this Abaqus Python we call it the constructor, right? So it's creating the some object. So that's why we are calling it as a constructor. And here in this we are giving some options, right? What is the name of that part, and what is the dimensionality, and some other information, right? Okay. So then what we are doing is we are using this sketch to extrude, to create the data of this part. So what we are doing, we are using the solid extrude, okay? What we are extruding, the sketch, and we are giving the depth as 20, right? So we are extruding the sketch to get the part. And at the end what we are doing, we are accessing the viewport. So here we are using the session database, right? So previously we have used the model database, now we are using the session, right? And from this session we are using the viewport, okay? This is the viewport name. And what we are doing, we are showing that object, this part object that we have created in this viewport. So this is like a setting this viewport, yeah. So when you run the script, it will show the model something like this. In this case, if you want to do some parameter study, then you can see this lines we have created, right? You just have to change these lines using some logic, and you can create a lot number of models here. So this was the model database script. Now we will see one output database script. Okay, so again the first will be some models importing. Then what we are doing here is we are opening the ODB. So here we have imported this visualization model, right? So using this visualization model only, we can open this ODB database. Then in this database, what we are doing here is we are accessing the step. So from the ODB, we are accessing the steps array, right? And the steps array, we are accessing this element, right? So step 1. So basically, we are accessing the step 1 from this ODB. Then from this step, my step, we are accessing the frames, right? From this frame, we are accessing the field outputs. So what type of field output is this? It's a displacement field output, right? Then similarly, we are from this frames, we are accessing the stress field output data, right? And then what we are doing, we are just manipulating it. So we are finding the difference of this displacement data from the second and first frame. Similarly, from the stress data from the second frame and stress data from the first frame, we are manipulating and finding the difference, right? Important point here is we can access the data, we can manipulate the data, right? And we can plot the contours also, right? So what we are doing here is we are showing the delta stress here. Okay, so that also we can do. So when you run the script, so this is the beam model data. So here you can see this is the legend. So here in the legend you can see S minus S, that is the difference of the stress, right? Minus S is the component invariant, right? And below there is a lot of important information. So the information is what is ODB name, then the what is the step name, session step, then what is the primary variable. Primary means what is the variable that you are seeing in this viewport. So that is the S minus S, that is this new contours that we have created. Okay, and from that contours stress data, what contours we are showing? We are showing the MySys contour, right?
So next is a deform variable. So here in the model, the deformation that you can see, right, is because of the deformed variable that we have set. So by default, Abaqus set the displacement as a deformed variable, but now we have changed that deformed variable also to the u minus u, that is a difference of the displacement value.
So you can see using this scripting, we can access the data, manipulate the data, and create some new field outputs also. This script is the same as the previous one, but what we are doing here is we can run the script using this the third method of we have seen, that is the Abaqus Python. So it doesn't require the Abaqus license, right? So the syntaxes will change us a bit, right? So as I told you, there will be some limitations to it, but still we can use it, right? So what I am doing here is I am using this ODB access now. So previously we were using the visualization, right? So visualization from we are able to open the ODB, but now we are using this ODB access to open the ODB. Okay, so that's why we are not using the visualization .odb. So we are using this open ODB. So so first one is the module import, then the ODB, open ODB, the same thing, then accessing the step, then the frame, then the field output, displacement field output, stress field output, and the manipulating the data, finding the difference of displacement data and stress data. See, this is not a GUI script, right? So that's why we cannot show the data on the GUI. So we cannot use any GUI options, right? So what I'm just doing is we are just saving the data to this text file. So in the delta displacement data, we are going to save this into the text file, right? So this is the text file that I have created. Okay. Yeah. Next session will be on the Abaqus object model. So till now you have seen two types of model, actually all the three types of model you have seen. The first one will be the model database object. So all related to the creating the model, manipulating the model, right? And the other one will be the session model, session object. So we can use the viewports, play with it, rotate the model, that kind of stuff. The last one and useful in the post-processing side is output database model. So these are just broad categories of the model databases that are there in the Abaqus. So as you can see, there are a lot of objects will be there. So almost 500 different types of models has been added by the Abaqus into the Python objects. At the end of this second session, we will learn how to use them efficiently. So how to find correct methods, where to look. So all this kind of stuff also we will see. Okay, so I think the next session is a more detailed one. So I think it will be a very much helpful and informative session going to be. So stay tuned and stay with this Abaqus Python YouTube channel, and the next video is coming soon. So stay safe, be hungry to learn. See you, bye, and tata.